Hello everyone, my name is Eric. I currently work as an electrical instrumentation and controls engineer based in Chicago, and I also have a bachelor's in electrical engineering. Today's video, the topic we'll be talking about will be circuits, and we'll be solving circuits using mesh analysis. These kinds of things are very crucial if you're looking for the currents flowing through some resistors, and you have complex circuits like these and other ones we're going to do throughout the video. This will be a great way to solve them. So let's get started. So for mesh analysis, what you're supposed to do is you're supposed to identify the kind of circuits that you see and basically establish where you want the currents to flow through them. So in this case, especially since we have a 5 current source on this left-hand side, we can assume and just say that we want the current direction to be going in this direction. And we'll call this I1. And on the other side, to just keep everything as simple as possible and easy for us to solve and get to a solution, we're going to also call this configuration I2. And we're going to solve it going clockwise as well. And essentially, the reason why I'm doing this is because what we'll be doing is kind of identifying where the current sources are going. And if we get a, let's say, a negative current source, then we know that essentially the loop is going the opposite direction. So for this case, what's nice about this problem is that we're actually given I1. So the current source for 5 amps is, the current source for this left-hand circuit is 5 amps. Now, I guess a question we can ask ourselves is, what is the current flowing through this 2 ohm resistor on the right-hand side, right? So let's figure that out. What is the current flowing through 2 ohms? So because we have I1, we're going to just write it down over here. Let's just say I1 is equal to 5 amps. Now, what's also important to notice is that this 5 ohm resistor actually is having 2 currents flowing through them, right? It's got the I1 current, and then it's also got the I2 current. But because this question is asking for the 2 ohm resistor, we're just going to solve for that one. So what we're going to do is, because we have this configuration going clockwise, I'm going to label our resistors going plus, minus, and in this case, it stays however it is based on the problem. And so what I'm trying to do is saying that if we are seeing the currents flowing this direction, it's going from a high to low, positive to negative, or I guess high to low flow, right? And so what we can do is let's start with this one because this is easier to start with. So we have the 2 ohms. So we can say 2. We're going to say minus 2I2 because it's flowing through high to low. So it's going from, we're going to subtract the 2 ohms multiplied by the current source to get a voltage. Minus, because we're going from high to low for this 10 voltage source. So we're going to say minus 10. And then we're also going to say minus 5 ohms. So we're going to say 5 ohms multiplied by I2. But what's also important is that we have to also subtract it by the I1 I1 current source, which is 5 amps. But we're just going to say 5I1. And we're going to put this in parentheses. So, and we're going to make this equal to 0. Because essentially what KCL is that the sum of currents is going to equal to 0. And so we're going to try to figure this out. So what's nice about this problem is that if we break this down, we can get minus 2I2 minus 10 minus, in this case, 5I2. And we got a minus, which means we have positive 5I1 equal to 0. And what's nice as well is that because we have our current source on the left-hand side and we know it's 5 amps because it's given to us, what we're going to do is just plug in 5 amps for I1. So let's put it together now. So we have equals minus 2I2. I2 is still our unknown variable. Minus 10 minus 5I2 plus 5 times 5, which is 25. So we're going to put 25 here. And so the only variable that we have to solve left, which is our I2. So essentially, if we do make this equal to 0, we're just going to essentially put this together. So minus 2i2 minus 5i2, which is minus 7i2. Positive 25 subtracted by minus 10, you get plus 15, so equals 0. And all we have to do left is that we put the 15 on the other side, or the negative 7, I2 doesn't matter, but in this case it will be 0. Minus 15 equals minus 7, I2. And all we have to do left, if you have a calculator, is get the I2 value. So all we're going to do is, if you have a calculator, do 15 divided by 7, and we get I2 is equal to 2.14 amps. And so what we identified is for this I2 current source on the right side here, we've identified it to be 2.14 amps. And then if we, let's say, the question also asks, what is the voltage flowing through the 2 ohm resistor? Then all we have to do is Ohm's law, right? So Ohm's law is voltage is equal to current times resistance. So if we have our current, which is 2.14, multiplied by 2 ohms, the voltage flowing through that resistor is 4.28 volts for 2 ohm resistor voltage. Awesome. So I'm going to erase the board. We're going to do a little bit of a more trickier problem and go from there. Okay. So I set up another problem here. It's a little bit more trickier, but it's definitely still reasonable, and we're definitely able to get to a solution. So essentially the question this time, what it's asking is, what is the voltage at the 5 ohm resistor? So for us to get the voltage, we would first need the current. So let's just walk through the problem and try to figure it out. So the first thing you're going to notice is the 2 amps going through the left-hand side. Like I mentioned, if you ever see a current source, whenever you're going to do emission analysis, that's always a good sign because it's basically kind of giving you the answer. So I'm going to do the same thing what we did in the previous problem. I'm going to kind of label my loops. So I'm going to call this one I1. I'm going to call this loop I2. I'm going to call this loop I3. So, like I said, the first one's nice because I1, we already identified that I1 is equal to 2 amps. Now, let's go through the second loop. So, if I did what I did previously, I kind of labeled my plus and minuses everywhere, kind of identifying how the current's flowing. Then I'll be able to kind of create a kind of system of equations for I2 and potentially I3. So in this case for I2, what I'm going to do is I'm going to do minus, because we always want to go from high to low. In this case, we're going to be subtracting from this, in this case, so it's going to be minus 5I2. Now don't forget, we still have I1 here, so we still have to go minus 5I1. Let me see if I have a better marker. And we're going to put this in parentheses. And then we're going to go minus 3I2. And then in this case, we go plus to minus, so it's minus 5 equals 0. Okay? And then let's do this. Let's break this down so then we can make it nice and simple so it visually looks nice to us. So we have minus 5I2 plus, because we have minus minus, plus 5I1 minus 3I2 minus 5 equals 0. And like I mentioned, we have our I1 here, right? So what we're going to do is we're going to plug 2 amps into our current I1 here. So you can break it down further. So we're going to have minus 5I2 plus 2 times 5, which is 10, minus 3I2 minus 5, which equals 0. And if you look at that, we're going to actually able to figure out what I2 is. So maybe a system of equations won't be needed for this problem. So our I2 current source, essentially if we break it down again, we're going to go 10 minus 5. So we get, let's do this, minus 5I2. So we have minus 8I2. Hopefully my marker is visible. And then we go plus 5 equals 0. So all we do is minus 8I2 bring the 5 on the other side. And so our current source, I2, is equal to 5 over 8. So if you have a calculator, 5 over 8 is equal to 0.625. 0.625. Awesome. And then all we have to do left is figure out the last loop. So I'm going to erase this. And we're going to be able to figure out what I3 is. Because now we've slowly kind of figured out what our current sources have been so far. So this time we have a voltage source from minus positive, so it's a positive voltage source going in this direction in the loop. So this is going to be positive. This is still going to go. It's going to be a negative. It's going to be a resistance against this voltage flow from this current source, right? So it's going to be subtract the 5 ohms, and then we also have another positive source over here, but it's going plus to minus, so it's still subtracting. So all we have to do is in this case we have 5 volts, so 5 minus the I3, which is going to be 5 volts. Yeah, that's right. Minus 5 I3 minus 1, which is equal to 0. And I guess actually, so if we do this, we do 5 minus 1, which is 4. So we have 4 over here, 5 I3 over here. I3 is actually 4 over 5. So then our I3 current source is 0.8 amps. Okay, awesome. And so if we wanted to just kind of figure out, well, so in this case, to answer the question, what is the voltage at the 5 ohm resistor, then all we're going to do is have to multiply the current, multiply by the resistance, right? So 5 times 8, or sorry, 5 times 0.8 is 4 volts. So there's 4 volts going through here, which makes sense because KVL, Kirchhoff's voltage law, states that the sum of voltages have to be 0. So if I have 5 volts going up through this direction, minus 4 volts minus 1 volt, that's 5 minus 5, which is 0. And so there we go. Easy peasy. So if you guys have any questions, any comments, leave it in the description or in the comments below. Leave a like, and yeah, take care.